Good day to us. Today we are going to be looking at isotopy. What is isotopy? Isotopy is a phenomenon whereby atoms of an element exhibit the same atomic number but different mass numbers. Why is this so? This is due to differences in the number of neutrons present in these atoms. If you look at an atom, the structure of an atom can be symbolically represented as this. So for an atom X could stand for sodium atom, could stand for chlorine atom, could stand for an atom of any element. So for such an atom, A represents the mass number, while Z represents the atomic number. The number of neutrons is given as the mass number minus the atomic number. And the mass number is given as the atomic number and the number of neutrons. If you check my video on atomic structure, this has been explained. So, when we say that isotopy is due to the differences in the number of neutrons, we mean that for a particular element, that it is possible for that particular atom to exist, but this existence is so much so that the number of neutrons in each case is different. For example, hydrogen has 3 isotopes. If we are saying that hydrogen has 3 isotopes, what does it mean? That means that hydrogen has the ability to exist in 3 forms which have the same atomic number, but the mass numbers are different. The 3 isotopes of hydrogen, as a consequence to what I have said, the first one is called protium. This is how it is represented. That means that protium has 1, the atomic number is 1, and the mass number is 1. So what would be the number of neutrons here? Number of neutrons here would be A minus Z. My A is 1 minus my Z is 1. That means that the number of neutrons here is 0. So protium has 0 neutron. Protium is simply called hydrogen. You simply call it hydrogen. In percentage abundance, this isotope of hydrogen has the highest percentage of abundance. Let's look at the second isotope called deuterium. Deuterium is also called heavy hydrogen. It has a mass number of 2 and an atomic number of 1. So the number of neutrons here is A minus Z, which is 2 minus 1, which is 1. So deuterium has 1 neutron. Deuterium forms oxides with oxygen, and the product we can also call what results from there, we call it heavy water, because it is an isotope of hydrogen that contains a mass number of 2, that has 1 neutron. Tritium. This is the third isotope of hydrogen with mass number of 3 and atomic number of 1. So what will be the number of neutrons? The number of neutrons will be A minus Z, which is 3 minus 1, and number of neutrons is 2. So this has 2 neutrons. This isotope of hydrogen is radioactive and it is rarely found in ordinary hydrogen. So protium has 0 neutrons, deuterium has 1 neutron, tritium has 2 neutrons. So you can see the differences in the number of neutrons. This is why hydrogen has 3 isotopic forms. Look at this question. The question says, the hydrogen isotope deuterium, which has lost 1 electron, now contains. When we're talking about the hydrogen isotope deuterium, what should come to your mind is this. The hydrogen isotope deuterium, sometimes you can just represent it as D. It has lost 1 electron. If it has lost 1 electron, it now contains what? If you look at option A, does it now contain 1 electron only? Know this. Sometimes, in answering questions like this, we have to start from the answer that we are sure that is not correct. This isotope has an atomic number of 1, and it is at ground state. There is no charge here. That means that atomic number is equals to the number of protons. Ground state equals to the number of electrons. That means this atom has 1 electron. If it has lost that 1 electron, now contains 1 electron only. No, it doesn't contain 1 electron. Now contains 1 electron and 1 proton. Well, it contains 1 proton, but it has lost electron. So it doesn't. B cannot be the answer. If you look at option D, contains 1 electron, 1 proton, and 2 neutrons. We have just calculated it here that it has just 1 neutron, so it can't be 2 neutrons. And we have said, since it lost 1 electron, it doesn't have 1 electron anymore. So C cannot be the answer. If you look at option C, it said 0 electron. Yes, it doesn't have electron anymore. 1 neutron. Yes. And 1 proton. 1 proton, atomic number is 1. Equals to number of protons. So this is correct. You can see how tricky that question was looking like. Question 2. Why is the relative atomic mass of chlorine 35.5? So why not 35? Or why not 36? That is approximated value just like other elements. Why is it 35.5? Before we answer this question, we have to define the term relative atomic mass. So what's relative atomic mass? The relative atomic mass of an element which exhibits isotopy is the average percentage composition of its various isotopes. The average percentage composition of the masses of its various isotopes as they occur naturally in any quantity of the element. So the average percentage composition of the masses as they occur naturally in any quantity of the element is what we mean by relative atomic mass of an atom that exhibits isotopy. Of course, chlorine exhibits isotopy, alright? And why is it 35.5? the relative atomic mass, or I can call it RAM, that's RAM, of chlorine is 35.5 because a given quantity of chlorine contains 75% of chlorine 35 and 25% of chlorine 37. 75% of and 25% of let's continue. So what's the implication of this? The implication of this is that the relative atomic mass of chlorine would be the sum of the average percentage compositions of these masses. Chlorine 35 is a chlorine atom with atomic mass of 35 and this with atomic mass of 37. That means there's a difference in the number of neutrons there. So let's look at this. Proceeding from there, it means 75% of this would give me, this is 75 over 100 times 35. The difference in these two atoms, is it? Mass of 35 and mass of 37. So 75% of 35, alright, plus 25% of 37. Yes. Putting that together with your calculator, you are going to have 25 goes here, 1 over 4 times 37. So at the end of the day, you would have a total sum of 35.5. You can check that out now. 3 times 35 divided by 4. Keep that answer. 1 times 37 divided by 4. Add the sum, you will have 35.5. Let's proceed. Why can't we approximate this value? Approximation here is very risky. If it was 35.9, it would have been safe to approximate. If it was 35.4 or 0.3 or 0.2, we can approximate it to 35. But we are having it at a midpoint, 35.5, 0.5. It is risky to approximate to 36. That is why it is safer to leave it at this value. Question 3. The relative atomic mass of naturally occurring lithium consisting of 90% lithium-7 and 10% lithium-6 is, it's simple, the average percentage composition of the atomic masses. So, I am going to have that for this, I have 90 over 100 times 7 plus this, I have 10 over 100 times 6. So, 90 times 7 gives me 630. You can check it up with your calculator. 9 times 7 is 63, 90 times 630 divided by 100. Plus 10 times 6 is 60 divided by 100. So, adding this together, we have, of course, the denominators are the same, so we can safely add that. So what we have is 690 over 100. 690 over 100, if you check it up, you are going to have 6.90, which is still the same thing as 6.9. So we have our correct answer there as D. That will be the relative atomic mass of naturally occurring lithium consisting of these percentage masses. A silicon containing ore has 92% of silicon 28, 5% of silicon 29, and 3% of silicon 30. Calculate the relative atomic mass of silicon. Which of them is correct? Relative atomic mass, RAM, is given as 92% of silicon 28 plus 5% of silicon 29 plus 3% of silicon 30. We proceed. Bringing up your calculator, what you're going to have would be 92 times 28. It's simply going to give you 2576. So we'll have 2576 all over 100. Okay, plus 5 times 29 is simply going to give you 145 all over 100, and 3 times 30 would obviously gives you 90 over 100. So putting this up, I would have 25.76. This is 1.45. This is 0.90. Summing it up, you are gonna have 28.11. That is gonna be your answer. Not C, but D. That is your relative atomic mass. Look at question 5. How many protons, neutrons, and electrons, respectively? From this word respectively, I'm going to follow the order in which I am given. Are present in the element this cobalt 60. Now, if you look at the value here is given as Z, while the value here is given as A. A is the mass number, Z is the atomic number. Remember, atomic number is the number of protons. So, protons here is 27. Yes. So, if you look at option A, respectively, I'm having 60 as the number of protons. That can never be the answer. If you look at option C, I am having 33 as the number of protons. That can never be the answer. So, this is a very good approach to handle an objective question. Moving forward from there, you can see that the possible answers is option B or D. Alright. So, neutrons. Don't forget, number of neutrons is given as A minus Z. What is A? A is 60. What is Z? Is 27. So 60 minus 27 is 33. 33. Yes. So protons, neutrons. So if you look at option B, 27, 33. It is possible that D is correct. Look at D, 27 and 33. Oh, it's also possible that D is correct. So we can't rush now. We need to test the last value. Yes. And electrons. Remember that this atom is at ground state. There is no charge here. At ground state, the number of protons, which is Z, is equal to the number of electrons. So if this is at ground state, and the number of protons is 27, which is Z, that means that the electrons will be 27. That means the last value is 27, but here is 33. So you can see the difference now. You can see the difference. So this is not the answer. My correct answer is option D. Yes. So you can see how cheap that would be. You need to be careful about this. These are just questions we just did playfully. So stay tuned for my next video. Like, subscribe, and share. I want to see your view in the comment section. If you love this video, share it to your friends. See you in my next class.